Today we're taking a look at section 6-4 on sampling distributions and estimators. We can learn about a population from a sample by studying the sampling distribution of a statistic. In particular, we will be looking at the sampling distributions, the sample means, and the sample proportions. So for our example, we want to consider a business that is only in business for 3 days because rude sales clerks, a poor business plan, poor advertising, a poor location, and so forth. During the 3 days the store is open, 1, 2, and 5 cell phones are sold. So that's the entire population. And 5. Alright, let's sample with replace so that the events are independent and list all possible samples of size 2. We could get a 1 and a 1, a 1 and a 2, a 1 and a 5, a 2 and a 1, a 2 and a 2, a 2 and a 5, a 5 and a 1, a 5 and a 2, or 5 and a 5. Now, what we want to do is find the mean of each of these samples. So the mean of the first sample, 1 plus 1 is 2, divided by 2 is 1. 1 plus 2 is 3, divided by 2 is 1.5. 1 plus 5 is 6, divided by 2 is 3, and so forth. So I add the 2 and divide by 2. Now, in the last column I have the sample proportion odd numbers. So 2 out of 2 are odd, so that's a 1. 1 out of 2 are odd, that would be a half. 2 out of 2 are odd, so that's 1. 1 out of 2 is odd, so that would be 0.5. 0 out of 2 are odd, so that would be a 0, and so forth. Now, let's consider the original population and calculate the population mean. We have a 1, a 2, and a 5. So 1 plus 2 plus 5 gives us 8. We divide that by 3. And the mean is 2.67 or 2.7. If we look at the population proportion of odd numbers, we have 2 odd numbers out of 3, so that would be 2/3 or 0.667. Now, let's consider the sample means we have up here. What we want to do is we want to take these sample means, all of these means that we have in the column, and we want to find the mean of the sample means. It sounds like double talk, and it is. We want to find the mean of the sample means. So I'm going to take 1 plus 1.5 plus 3 plus 1.5 plus 2 plus 3.5 plus 3 plus 3.5 plus 5. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9 sample means that we're working with. So I want to divide 24 by 9, and I get 2.666 repeating, so 2.7. So the mean of the sample means is 2.7. Alright, the sample proportions, I want to find the mean of those. 1 plus a half plus 1 plus a half plus 0 plus a half plus 1 plus a half plus 1, and again I have 9 of them. Again, it's a 6 repeating, so that's, I know that is the number 2/3. Okay, so what do we note? Well, what we want to note is that the mean of the sample means is the same as the population mean, and the mean of the proportion of odd values is the same as the population proportion. So It's very interesting that the mean of sample means, and sometimes the way they write the mean of the sample means, you may see this notation. So the mean of the sample means is equal to the mean of the population. Okay, so sampling distribution of the mean or the proportion. The probability distribution of sample means or sample proportions with all samples having the same size n. So we just show that probability distribution. Now, the sample mean, the sample variance, and the sample proportion are statistics that target the population parameters. However, the sample median, the sample range, and the sample standard deviation do not target the population parameters. So in the book, they focus on all three of these. I'm just going to focus on the two. You may see some information on the sample variance in there, but in the textbook, but we'll focus primarily on the sample mean and the sample proportion.